So I welcome you all again to this Math 371 and computing lecture of Matlab. So I have given you about 20 to 25 minutes so that you can try your best to write a Matlab code for the composite Simpson's rule. And I hope some of you would have been able to do it. And if you are unable to do it, then please now consider uh, what I will teach you from onwards. So now pay attention to this MATLAB editor. So I'm going to write for you from the beginning. And one thing that you must know is that what is the Simpson's composite formula, and similarly for the composite trapezoidal rule. So if you understand the formula yourself and you have a basic knowledge about the MATLAB, so you can write this small code for yourself. And now I would like to write from the beginning. Now you can see the MATLAB editor in front of you, and in the first line I have given that what we are going to do, write a MATLAB code for the composite Simpson rule, and for the function f of x is equal to e power x, and a is given 0 and b is 4, and the number of subintervals that you will consider is n is equal to 4. Okay, so what we need again is to start from the beginning. So we write CLC here and close all, and then we define our function, and we know that how to define the function now. F is equal to at the rate of x, and then the function exp of x. Okay, and now you will write the values a is equal to 0, b equal to 4, and n equal to 4. And then since you will try your best to write the formula for Simpson rule, so write Simpson is equal to h over 3 and then into something, and if you remember the formula, what was it? F of a, and then plus 2 times some sum, we don't know the sum, and plus also 4 times into some sum, and then plus f of b. So this was the formula. Now the question is this: what is the sum? Or if you want to write sum 1 and sum 2, it is up to you. You can write sum 1, calculate separately, or you can also use some simplified form. So you can say this is your sum 1, this is your sum 2, and also I'm trying a new experiment actually, and let's see in how many minutes I am successful. So we need h, and what was the h? If you remember, b minus a over n. Okay, and then since we are interested in finding the sum, and there are 2 sums, so we have some loop for sum 1 and we have some loop for sum 2. Okay, now what we will do, we define this sum 1 start from 0, any sum start from 0, and then you add sum 1 is equal to sum 1 and then plus something, and similarly for this you define sum 2 from 0, okay, and then you write sum 2 is equal to sum 2 plus something. So I'm giving you how you think when you are writing something. You pay attention to the formula and then you pay attention to some algorithm thing that what we are going to do. Okay, so we are much closer to the formula now. Now the question is how to write this sum 1. So now if you remember the formula, actually I have to open the book, and it was 2 times f of sum of even functions and plus 4 times of odd function. So if you remember, it was like f of a, then, or I should write where, so I make a comment here. And what was the sum? So this was sum was f of, this was f of x2 if you remember, and then f of x4, so on. This is what it is sum here. And now what was sum 2? Now what was sum 2 if you remember? If you remember the 3 point x naught x1 x2, so what was this? X naught plus 4 times f of x1, 4 times f of x1, so it was f of 1 and then f of x3 and so on. Okay, now pay attention how to write this this f of x2. So now if you want to write f of x2, so you have to write a plus, now you define some loop. I start from 1 to n for example, and I will make correction for you, and here you can say I start from 1 to n. Okay, now we have to see that where we have to start and where we have to go. So where uh, h, remember what was f of x naught or f of x1? So if you want to see what is f of x2 and what is f of x1, so how to write it? F of a plus I into h. Okay, now we have to make correction to this only loops. So this loops says we have only values which starts from this number. So we have to make a gap of 2 for every point. So because we consider, so this 2 means that we start from 1, then we make a difference of 2, and then we move to a 3. So it starts from 1, then it goes to 3, and then 5, and then 7, and so on. Similarly this one. So we have to adjust this thing now. So we have to see that it is -1 or it is -2. So what I mean, if I put a plus h, so actually it should start from 2. So you agree with my statement, and when it starts from 2, so it must stop in -2, and then we come up with this from 1, because when we put I1, so what will be f of x1? F of x naught plus h. You remember the formula of x1? Now pay attention to this one first and then this second one later. So we are interested to find the sum of f of x1, f of x3, f of x5 up to n minus 1. Okay, so for this we have constructed a loop. I start from 1 and so that this value will become f of x1, and then we make a difference of 2. I will be 3. So if I is 3, so a naught x naught plus 3h will be over f of x3. I think it is now clear if you know the formula. And now similarly, what about this f of x2? So what is f of x2? F of x naught plus 2h. You remember f of x2? If I write this for you as well. So what was this? Of x naught, which is actually nothing but a plus 2h. Similarly, this is equal to f of x naught plus 4h. You remember this? And now you can see this is equal to f of x naught plus h. And similarly, this f of x3 is equal to f of x naught plus 3h. You got my point now? So now if you pay attention, I think you are able to find this sum and this sum as well. So now let's the last thing. Okay, you must just remove this and run it. So first we save somewhere. This is Simpson, composite Simpson. So you can see Simpson is 53 point this one. So this is very wrong. So because what is the exact value? What is the exact value? You know that the integration is exp of 4. Let's see if it's correct or not. Exp of 0. So this is the exact. Let's see. So oh, we are close. And if you want to see the error, so what is the error? Exact minus Simpson. Okay, so you see the error. And to make an absolute error, so ABS, absolute of this thing. Okay, so we are not very good because we have just taken N4. So what about if we take N10? See, so you see, by taking N, we are now close to 2 decimal accuracy. So what about if we take N20? N20, so you see we are 3 decimal, more than 3 decimal accurate. So the more N we take, the more accurate we get the answer. So I hope now you get the idea that to write a code uh, start from 0. So I tried to avoid the complicated coding and I try my best to write a very simple code for you so that you can, if you are a beginner like me, then you can write just by thinking the step what is going to happen. And now the thing is that you how to write this in a very good form. So you can write the command fprintf, and you can write all this in one line if you want, and if you want you can write this in 3 lines. You can say or you can say composite. Since you want to write an answer with a percentage signs, so 5 point, if you want to write just 4 decimal or up to 8 decimal, it is up to you. Then backslash n and then the answer. This is the one way, and similarly you can write, and now you don't need to write it again and again. You just copy this. You can just say value, and then you say here absolute error. Now just comment this now, and now you can see a very good way that composite Simpson rule give you 53.599. And moreover, if you want to write more special thing like you changing the n, so you can say composite Simpson rule this using n equals, and then you put a n here so that you know what is n. Let's see what I mean. So now you can see how many n's you have used. Okay, you got my point. So for example, if you change this one, you see using n, this I mean. Okay, so you can see now that I have run. So similarly, I ask you to write a MATLAB code for composite trapezoidal rule. So what you have to do now or at home, that write a MATLAB code for composite trapezoidal rule following the same procedure, but now the formula will be much easier for you because in trapezoidal rule, so what is trapezoidal rule says? So trapezoidal is just, I think, a h over 2, sorry, h over 2, and then multiply by f of a, and then plus sum, and then plus f of b, and then this sum is, if I remember, is multiplied 2 times. So the question is this, what will be the sum? So sum, this is what you have to find actually. This is the only thing. The rest is similar. So I hope you have learned today that how to write a Matlab composite Simpson rule code, and now you can change the function as well. So for example, you have x square. You remember x square? Now run it. So this is error because of this thing. So I comment this. So using n4, the error is too big for this function, and because it is, so we have to take something, let's say 40. So but what is the wrong thing? Because exact is now changed. So the exact value, what is the exact value now? So it is exact will be x power 3 over 3. You got my point? Wait, this is a mistake because we changed the function. Now exact function is changed, and we have to put this x as well 4. So it is nothing but a 4 power 3 minus 0 power 3. So now you can see the error because we have taken n too much. Let's try this one. Oh, this is okay. The Simpson rule. Okay, so Simpson rule is good and give you exact value when you have quadratic. So what about if we have a cubic? So now you see the error comes, and you can try different functions. For example, sine of x. Now pay attention, when you write sine of x, you have to change the exact thing. Okay, so I think now the things are very much clear to you, and I expect that you practice. And in the next week, maybe we have our second quiz online, and I will let you know when. And most probably it will be online, some MCQs, and you have to prepare for it for chapter number 4 and 5.1, and most probably 5.2 as well. So from my side, this is all, and I thank you very much for listening.